Welcome to GitHub Gallery Part 4, JAWA, Jamf Automation and Webhook Assistant. I am your host today, Christopher Ball. You may call me Chris. I am a co-author of the JAWA project on GitHub. I'm also an implementation engineer here at Jamf, specializing in automation and integrations for customers and prospective customers. Not pictured, but co-author of JAWA is another implementation engineer here at Jamf named Jonathan Uresco. Huge shout out to him. Without him, we couldn't have done this. So thank you, Jonathan. Okay, let's begin. This, once again, is GitHub Gallery Part 4, JAWA Edition. Today, we're going to talk a little bit about Jamf Pro webhooks and webhook events. We're going to talk about what JAWA is. We're going to show some specific use cases so you can get a feel for JAWA, see if it's right for your environment. And finally, if you are interested in JAWA, we're going to have some tidbits at the end that are going to let you know how you can monitor the services that are running on the server and where you can check to make changes if you need to. And at the end, we'll have some information if you're dying to find out more information about JAWA or other things that we reference in this keynote. We'll have a slide at the end with links for you. So let's start from the top. In Jamf world, what are Jamf webhooks? Well, to borrow a line from the developer portal, webhooks allow you to subscribe to specific events on a Jamf Pro instance. And what that means is whenever specific events, things that are occurring within your Jamf Pro environment organically occur, and a transmission is sent from your Jamf Pro server to a listening server containing information about that event and the device to which the event occurred. Now, what Jamf Pro events do we have available to us? Well, today we have a lot of events available, as you can see in the middle of this slide. Think about the common everyday things that are occurring in your Jamf Pro server, and we probably have an event for it. You add a computer to your management fleet. That's our computer added event. Mobile device is enrolled. We have a mobile device enrolled event. Devices check in, update inventory, not just device level. We could also have server events like the Jamf Pro servers started or stopped. All of these events we can gather information about and send somewhere else so that we can then do more with that information. So now we know a little bit about what webhooks are in the Jamf context. Let's talk about what JAWA is. Well, at its core, JAWA is a webhook receiver that was built with Jamf in mind, and it leverages both webhook and cron. It has a web front end for the admin to interact with the server, but on the back end, we have two major services, webhook, cron. Now, who does this help? Immediately, it helps your Jamf Pro admins by helping them achieve scalable and repetitive tasks with ease, headlessly. Now, if we could free up these Jamf admins from their day-to-day monotonous routines of these everyday thoughtless tasks, we could also save time for everyone else who might be waiting for a Jamf Pro admin to act on a request or waiting for approval from a certain entity. A lot of places where we see delay in processes, it's due to human error or just human workload. How does JAWA work? Well, it is an HTTP webhook receiver. It's configured to receive, like I said, transmissions over the web containing information about Jamf Pro events. It also has a cron assistant that lets you set up scheduled tasks so that you can run events at a certain time on a certain day or at a certain frequency. I'd mentioned it's a Flask application. It's powered by Python, but that's just the web front end. It could also run Python scripts or Bash scripts, Z shell scripts, or whatever language you might prefer to script in. As long as you have that available on the server itself, it can run that as well. So when do our automations run? In JAWA, I like to think of it as two different flavors of automations. We have reactive and proactive. Our reactive automations will be our webhooks that we add to the JAWA server. These are things that are coming in from Jamf Pro. We're not sure when these events are going to come in, so we need to make sure the server is reactive and on and ready. Our proactive events are things that we do know when they need to occur, things that we have planned out. And these events are going to utilize cron. So we have reactive events, webhooks, proactive events with cron, trying to cover all of our bases as efficiently as possible. So why use JAWA? Well, if not JAWA, I would still recommend looking at a webhook receiver out there somewhere, something like AWS Lambda or Zapier, because automation saves you time. And like I said, it also saves your end users time. Webhooks also extend your management capabilities to where you can do more upon devices automatically whenever things are occurring. And cron jobs allow you to remove the burden of repetitive tasks, so you don't have to spend more hours of your day doing the same task over and over again, where you're no longer perhaps growing professionally because it's become mindless. So my goal is for us to build robots so that we can all become more efficient humans and make everybody happier in our day-to-day lives. So what can JAWA do? As I mentioned, it can add webhook automations. It can also edit and delete them. The same thing for cron tab automations. You can do this all within the web UI. It has a Jamf Pro Server webhook integration built in. And what that means is when you create a webhook on the JAWA side, we are in tandem creating a webhook in the Jamf Pro interface as well. Same occurs if we're editing the webhook on the JAWA side, that webhook piece is edited on the Jamf side as well. And it's going to have information automatically populated, like what the webhook URL will be that we're sending the information, that it will automatically add encryption, and it will also select the JSON event type for us and the appropriate Jamf Pro event. It also has Okta webhook capability for any of you using Okta in your shop. It can register itself automatically with Okta when you have a token. And then you can use JAWA to listen to events such as accounts added or deactivated from your Okta environment. Now, the bottom line, maybe, that some of you might be asking is, how much does this cost? Well, this is Github Gallery, so it's absolutely free. It's open source. You can go out today and grab it. It only costs you whatever it costs to spin up a server. Okay, now we know a little bit about JAWA. Let's go through some examples and use cases to get you an idea about when you might use a webhook receiver and automations, and hopefully get some ideas generated that you can take home in your environment. Start with goal 1, setting sites and device names dynamically and automatically. Our goal is for tvOS and iOS devices to have both their site and their device name set automatically at enrollment. We don't know when devices will enroll. We just know that they will. Now, the iOS and iPads should have a device name that matches the user of the device. And then the tvOS names should match the room where the device lives. It doesn't have a true owner. It belongs to the room. Now, let's talk about some problems if we were trying to solve for this with just the Jamf Pro Server UI itself. Well, we do have default device names from our pre-stage enrollment, but those default device names are not always useful when we're actually trying to identify the device. Serial number is definitely identifying, but not immediately. You have to look it up to figure out exactly what device this serial number belongs to. The default name of iPad is especially unhelpful. If you've ever searched through your Jamf Pro environment looking for a specific device and you come across one named iPad, you might wonder, well, what device is this really? So default names can be a problem. Also, timing. The Jamf Pro admin, like I said, might not be available or aware whenever a device is being enrolled. We don't know when someone's going to actually take an iPad out of the box and set it up. So once again, the Jamf Pro admin might not be available to instruct the person to name it correctly or to set the name from the UI at the appropriate time. We also have human error as we go through this task repetitively. The human brain gets tired and we can begin to make mistakes, maybe skipping down a row or over a column by accident, inverting letters in a serial number or asset tag, etc. Human error is bound to occur if we continue with human processes. Last problem for this scenario is our source of truth. How can we know what the device's information is pre-enrollment? Well, that one we can solve with Jamf Pro, but we just can't put it in the place that we want it. Let's take a look at how we can use JAWA to solve for this problem, though. So in JAWA, we could create a webhook that will run at the specific event mobile device enrolled, and when it runs, the script will determine the type of device that it is rolling, whether it's an Apple TV or an iPad. It will then use inventory preload information to determine what the appropriate site and device name is. And then once it figures that information out, it's going to set that site and change the name. And it's also at the same time going to be flexible in case we didn't have the information. We're going to set that device aside in a group that is designated for remediation tasks. Here we can take a look at a workflow for how this would work. We start on the left-hand side where we see our webhook icon. The Jamf Pro server received a mobile device enrolled into the Jamf Pro server. So the Jamf Pro server sends an event, a mobile device enrollment event, up to JAWA. JAWA then begins running the script that is parsing information about this device. Its first determination is this an Apple TV or is this an iPad? And based on which one it is, it will take specific information that it gathered that was provided via inventory preload. And then it takes that information and it's going to apply it somewhere else. Now for setting the site, we're going to edit the mobile record. And then for setting the name, we're actually going to send a specific command called set mobile device name. After we gather what we're going to do, we then send a REST API update over to the Jamf Pro server, and that information is effectively changed on the device itself. We now have devices with human-readable names without you having to lift a finger at time of enrollment. Now, this does have to have the information in inventory preload beforehand, so you'll have to do some work up front, but a little bit of work up front can save you countless hours of monotonous tasks down the road. Okay, example 2, REST API event logging. Our goal in this example is to log all REST API events. Any event that is occurring against your Jamf Pro Classic API. We're going to email a daily summary of all REST API events, either to IT or InfoSec. And we also want to be able to alert IT if we detect that violations are occurring that exceed our specified threshold. Think, 10 wrong password attempts within 10 seconds, maybe 100 attempts within a minute. Whatever threshold seems unreasonable to you and you'd want to be reported on, that's our goal. All right, problems with accomplishing this with just the Jamf Pro UI itself. Well, not all REST API events are logged by default, for one. You'd have to turn on some verbose logging to see all of this. And for two, the information itself is kind of hard to parse out with everything else that might be occurring within your Jamf Pro server log. So it's difficult for a human to sort through all of this information, gather only the necessary pieces, collect that into a report, and then on top of that, we have to take this report and email it every single day to a group of people. This is a monotonous task. It does not sound like something that you'd really love doing every single day. So if we can get a robot to do it, I feel like that's a huge win. And the good news is we can. Our solution with JAWA is a two-part solution. The first part will be a webhook in JAWA that runs during the REST API operation event. And it will kick off a script that logs to a file information about that event. It will let you know what the attempted action was, what time of day, the username that attempted it, what endpoint they were attempting to access, whether or not they were creating or updating and changing things, and then whether or not they were successful ultimately. After we log all that information, the script will go further to detect if there was a violation, if we've met the threshold for the number of violations, to then send an alert. Now, this alert is a vague term. It could be anything that you could connect with. You could be sending an email or a text message to a specific technician, You could be sending a Slack message to a team. You could also be opening an incident in your ticketing system. That's really any system that you're able to communicate with, we could work into this workflow. The second part of this solution with JAWA would be a scheduled task that we're running every day to gather the daily log file, what's occurred in the last 24 hours, and send it in an emailed report either to IT or to InfoSec. So once again, let's take a look at how this looks in flowchart form. Our top row is our webhook workflow. It's kicked off by a RestAPI event, which goes to our Jamf Pro server. The event is parsed by JAWA. The event information about that attempt is sent in an event to JAWA, which is then parsed by a JAWA script that gathers information about the event and logs that to the file. After it's done logging that specific, the most recent event to the file, it determines, have we met the threshold for violations? And if so, we're going to send an alert. If not, our task is done. We've logged it to the file and we'll wait for the next attempt. Now, the second part of this solution is our second row. This is a cron tab daily task. This one could be kicked off maybe at midnight or something, and it just runs headlessly on the JAWA server itself. JAWA will kick off a script that looks at the log file, gathers the last 24 hours of data, and then sends it in an email report out to the appropriate people. Easy peasy. Okay, so shifting gears a little bit out of the API and into the school world, let's talk about school time restrictions. Now, this might be a common goal out there, especially here in 2020, as we might have struggles with virtual learning. But our goal in this scenario is to apply iOS restrictions only during school hours, Monday through Friday. While we're applying these restrictions, we're only going to permit certain approved apps for school use and restrict the students from playing games or anything of that sort. The goal is to make sure that students are empowered to be as engaged in learning as possible while they may be either in the classroom or learning at home. The second part of this goal is to actually lift the restrictions after school hours. While we do want to make sure that they are focused and engaged within our time at school, we don't want to limit their capacity to use the iPad for other things that their parents have approved outside of school hours. So we want to both apply and remove restrictions on the same day automatically. Now, if we were looking at doing this with the UI, I could see a few problems because this really does not scale well. This is a huge repetitive task that an admin would have to take on every school day to make sure that the appropriate changes are made in the Jamf Pro server to apply these restrictions via a configuration profile to our student devices. My head is spinning just thinking about the idea of doing this at scale with hundreds, if not thousands, of devices on a daily basis. Not only do you have to set the restrictions in the morning, you have to remember to unset them at the end. And please don't miss a day of work because we're counting on you for our students to be focused. This sets us up for failure if we were attempting to accomplish this workflow manually through the UI. How can we solve for it with JAWA? Well, you guessed it, scheduled tasks will have two cron jobs in this case. One that runs at the beginning of school, maybe 7:30, that is setting the devices into a restricted mode, and the other one will just run at the end to unrestrict them. When these cron tasks kick off, the script will check what the current day is. If it's the weekend, it's not going to do anything because this only applies to Monday through Friday. And then on the weekdays, the pair of cron tasks will set an extension attribute value, maybe school time restrictions. It will set that to true for student devices at the beginning and then set it to false at the end of the day. We'll have a configuration profile and smart groups that are scoped to these specific extension attribute values so we can remove and add the restrictions effectively. Here is another flowchart. Our top row is our morning cron job. JAWA runs this job maybe 7:30. It first checks, the script checks to see if it's a weekday. If not, have a great weekend, move about your day. But if it is a weekday, we want to make some changes on the Jamf Pro servers, we're going to send an API command to update the extension attribute of student devices. And as a result, some rescoping occurs on the Jamf Pro server, restriction profiles are sent out, and student devices are restricted. The second task, automatically run at the end of day, maybe 3:30. The cron job kicks off automatically, similar flow, checking to see if it's a weekend. If it's not the weekend and we have it's Monday through Friday, we'll go ahead and change all of those devices back to our unrestricted state. This is, once again, making an API call to change the extension attribute value of student devices. We took what would have been a huge, painful task for an admin to do manually through the UI, and we made it into a headless task that they just have to keep eyes on daily. Okay, our last example is tackling maybe one of the older problems in the iOS world, at least for large organizations, is determining, whose iPad is this? What iPad is this? I can't tell at a glance from the lock screen anything about this iPad. So our goal in this workflow was to apply some useful information via a wallpaper to the iPad so that if somebody finds a lost iPad or is just trying to identify iPads on the fly, they can look at the screen and maybe figure that out. Identifying information that we have in Jamf Pro could be things like asset tag or device name. We might want to know what iOS version it's on, what building department, etc. Now, how is this a problem if we're trying to do this manually through the UI? Well, manual wallpapers do not scale well at all for a lot of reasons. For one, it takes a lot of time to prepare individual wallpapers by hand. Imagine doing photo editing for hundreds or thousands of devices, and you need to make sure that you have it just right, and then you need to make sure you're sending each wallpaper to each individual device. This becomes a hairy process just in thinking about it, and not to mention the fact that device information is not static. Device information can and will change as devices change hands. So if you did make wallpapers in advance, well, I have bad news for you because you're going to have to make some more when information and devices change. So the good news is we can solve for this automatically. You don't have to do everything manually. With JAWA, you could have a webhook and or a timed job script, depending if you wanted it to occur at a certain event or if you wanted to just reapply wallpapers at a given cadence. But the solution is to gather that information about devices from the Jamf Pro API. We're going to overlay useful information onto a wallpaper template, which then we can send to a device, and we'll do this all programmatically. If we were setting up this webhook in the Jamf Pro server, the JAWA server, you would click on JAWA and then click on New Webhook or Create a New Webhook. Give it a name. Make sure it doesn't have spaces. Select your Jamf Pro event. In this case, you might want to apply the wallpaper at enrollment. So I chose mobile device enrolled for my event. And then grab the script that you're going to run that is doing all of your parsing and all of your changes. In this case, building the wallpaper templates. You'll add that into the UI, hit submit, and then in your JAWA dashboard, you'll see some useful information at a glance about the endpoints that are enabled, what event in Jamf they're listening for, what script specifically they're running, and then any friendly description that you might have added. So let's take a look at the flowchart for custom wallpapers. If we look in the left-hand side where we have the big start button that's on top of the mobile devices square, that's where we begin. A mobile device is enrolling in the Jamf Pro server, and then we move up from there where the mobile device enrollment event is being sent from Jamf Pro to JAWA. JAWA is parsing this information and then gathering more information about the device, identifying information like building, department, room, username, etc. And then it's taking the desired information and applying it as a text overlay on top of a wallpaper template. And then that custom wallpaper that we've created with our identifying text is sent back to the Jamf Pro server via an API command, and ultimately it's sent back down to the wallpaper itself as a wallpaper. Back down to the device itself as a wallpaper. This is information that we already have at your disposal in Jamf Pro, and once you get this workflow in place, it is another headless automation that you just have to keep an eye on to make sure that everything is working smoothly. Now, I've said you just want to keep an eye on a few times during this presentation, so I want to let you know a little bit about the server and how you can keep an eye on things. But first, let's talk about what you need to get this server stood up. Currently, it runs only on Ubuntu server. We do have a Red Hat version that is coming soon. It's in testing as we speak. The hardware resources required are very limited. We recommend 2 gigs of RAM, 20 gigs of storage, 2 cores, but it could actually get by with a lot less. That's just future proofing recommendations. From the networking side, we need port 443 open. 443 is the port that the JAWA server is listening for webhook events. So if it needs to be open inbound from your Jamf Pro server, and possibly from Okta as well if you're using an Okta integration. It also needs outbound 443 access to your Jamf Pro server and any other port or services that you need your workflows to access. And of course, if you're using an on-premise Jamf Pro server with a port different from 443, maybe 8443, you would want to open that port instead, outbound. Okay, you definitely want to have an SSL or TLS certificate and private key for your JAWA server. This is ensuring that the webhook events sent from Jamf will be encrypted. And also when you're accessing the web UI, your information is encrypted in there as well. So when we're managing and monitoring our JAWA services, there are a couple of custom services that we built for JAWA that you can check from the command line of the server. Using the journal control command. Now the services are webhook.service and jawa.service. The webhook service will give you information about incoming webhook events and any outputs that you have within your webhook scripts. And the JAWA service will let you know what's going on with the web page itself as you're clicking through and interacting with it. If you have issues with either one, use journal control to try to narrow down what the issue might be. And if you do have an issue and you need to restart it, system control or systemctl is your best friend. You can systemctl restart webhook service or JAWA service to restart either of those. But there is another service that you might consider restarting, and that's Nginx. Nginx is proxying our connections. So if you have issues with connecting via webhook or to the UI, or if you're changing your certificates, you're going to have to restart the Nginx service. So keep that in mind. There are some locations of interest if you're using the JAWA server. I want you to take note. In USR local JAWA scripts, we have all of our automation scripts that you've uploaded via the UI. They are tagged with the name of the endpoint as well, just in case you use the same script for multiple workflows. You can keep track of which one is which. Also within the JAWA directory, we have a WebAct directory that contains a server.json. This is a configuration file where the JAWA FQDN is stored, as well as the Jamf Pro URL. If you are having difficulty changing either of these things via the UI, feel free to change it at this file itself. Okay, /etc/SSL/certs is where we're keeping our JAWA certificate and key. These are stored as jawa.cert, jawa.key. There's information about the certificates on the GitHub if you have questions. But if you ever need to change the certificates, I want you to know this is the location where we store them. And last but not least, in /etc, we have the webhook.conf file, and that's going to contain information about all the JAWA webhooks that we've uploaded, what endpoint that we're listening on, what script we're running, context for that script, etc. And please remember, as you're setting up workflows in your environment, you want to make sure that you have any resources that this workflow depends on installed beforehand. So if your workflow requires a specific Linux package, make sure that package is installed on the server. It's a good method to test this is just run it manually first to see if you can perform the action before you try to automate it. Once again, from the JAWA server. And again, please make sure your TLS SSL certificate is in place and that your CA is trusted by the Jamf Pro server. Self-signed certificates might have a hard time with Jamf Cloud. Also, you might consider using the combo certificate or a full chain certificate for your certificate file. I found that sometimes Jamf Pro likes that a little more than just the server certificate. And last but not least, be excellent to each other, everybody. I hope that you learned something or maybe just got some ideas about how you can take webhooks and automations and improve your environment in your daily lives. I hope you enjoy. If you have any questions or you'd like to know more, we do have our GitHub page, github.com/jamf/JAWA. We also have the Jamf Pro developers portal at jamf.com/developers. Where you can find out information about webhook events and how to interact with our API. Speaking of the API, you can have the best information about your API is probably found on your Jamf Pro server itself at your Jamf Pro server's URL/API. And last but not least, huge shout out to Adnan H's webhook project on GitHub. We are leveraging this in JAWA. So thank you so much, Adnan, for creating this. I wouldn't be here to talk to y'all today if you hadn't. Thank you, everybody. If you'd like to know more, once again, reach out to us on GitHub. I'm on Slack as Ball42. Have a great day.